Hey everyone. So, as part of that stuff that College Board released in 2019 about how our exam was changing, this is another one of those topics that, well, I haven't worked it quite in to the curriculum yet. So that's why it's in your spring break packet. Okay, so this is integrals involving long division and completing the square. Okay. And we'll just do a couple of each. This first problem, integral from 1 to e not 2, of x squared plus 1 over x dx. Okay, well, this is not a completing the square problem. This is, in fact, a long division problem. Though, I'm going to do it with long division, but just let's say minus x squared over x plus 1 over x dx. And so really I'm just integrating 1 to e of x plus x to the minus 1. And what's the big deal? I don't need long division here. Yeah, so they want us to do long division. And, there may well be some cases that we see where, ooh, no, I really do need long division. So let's take a look at long division here. Don't forget your 0 placeholder. So x into this, x times, and subtract, and we've got a 1 left over, and so this is 1 over x. Oh, so all that did for me was split that into two fractions. That seems kind of lame. And I'm going from 1 to e. Do I need to evaluate? Yes, I do need to evaluate. So this is going to be x squared over 2, antiderivative, plus ln of x. And we're going from 1 to e squared over 2 plus ln of e is 1 minus 1 half plus 0. So that's going to be e squared. 1 minus a half is 1 half over that 2. And it's a plus, and that's choice B. B for number 1. Okay, number 2. Number 2, integral 1 over x squared minus 2x plus 2 dx. Now, for me, the first thing I thought about is this partial fraction decomposition? And the answer is no. Why is the answer no? Because I can't factor that. So this is what completing the square looks like. So here's what we're going to do. We're going to take that x stuff, and we're going to sort of put it together here, and then have that plus 2. Now, what is it that we need to add in here to turn this into a perfect square trinomial? Well, that magic amount is b over 2 squared. My b value is negative 2. Negative 2 divided by 2 is negative 1, and negative 1 squared is 1. Now, I'm adding 1 on the inside here, so I have to subtract 1 here. Yeah, no, really. There's no equal sign here where we would be adding 1 to both sides of the equation. There's just us on one side, and so simultaneously I'm adding 1 and subtracting 1. So what am I now going to have on my bottom? I'm going to have x minus 1 squared, and then here plus 1 over dx integral. Now, hopefully you see that this is an inverse tangent because I have things squared plus 1 in the denominator. You can use a u sub for this. Du will just be dx. And so you'd be rewriting this as 1 over u squared plus 1 du. That's definitely inverse tangent of u. And so we're going to plug that back in for our u. And arc tan x minus 1 plus c. Choice E. Good. Tangent inverse u plus c is where that takes me. And so this is E for number 2. Okay, you might want to watch that again, but maybe you want to actually just take a look at number 4 when we do that. 3. 3 is the integral from 1 to 2 of x squared minus x minus 5. And this is x plus 2 dx. And here again, I think, ooh, can I factor that and cancel factors? Or is this partial fraction? Oh no, I need more stuff on the bottom than I do on the top. So yeah, that's not factoring. So really, this is what long division is made for. X squared minus x minus 5. Okay, so what do I multiply this by to turn it to that? An x. X squared plus 2x, and I subtract. Minus 3x minus 5. What do I multiply that by to turn it to this? It's going to be a negative 3. Minus 3x minus 6, and I subtract, and I get 1. So plus 1 over x plus 2. All right, so what's our quotient? It's x minus 3 plus 1 over x plus 2. Now, why did I want to do that? Well, this thing here, dx, and that's minus 5. This thing that I can't figure out how to integrate can actually, with long division, be rewritten to x minus 3 plus 1 over x plus 2 dx. This should be wicked easy to find the antiderivative of. And this, if you're not sure, it is an ln. You could do a u sub. So du equals dx. And so that would be the integral of 1 over u du. Well, that's just ln of u. So ln x plus 2. It's a definite integral, so I want to plug in my 1 and my 2. 4 divided by 2 is 2, minus 6 plus ln of 4. And then minus, I plug in a 1, I get 1 half, minus 3 plus ln of 3. All right. Are we taking this further? We're taking this further. Okay. I like multiple choice because then I get to see, am I really doing it right? And it's going to be negative 4 plus ln of 4. Okay, that's 6 halves. So it's negative 5 halves. Minus a minus is plus 5 halves. Minus ln of 3. Okay, so that's minus 8 plus 5 is minus 3 halves plus ln of 4 minus ln of 3. 2 logs joined with a minus is going to be ln of 4 thirds plus negative 3 halves. Okay, ln of 4 thirds and minus 3 halves, that's choice A, number 3. All right, yay, long division. Yeah, so don't view these techniques as a punishment. They're actually taking things that are rather impossible and turning them into things that we can integrate. And this is a plus 5. If this were a minus 5, I could just factor here and use partial fraction decomposition. But that's not going to factor for me. So I'm going to do completing the square. I'm going to put all the x stuff together, and I'm going to push off to the side this 5. In here, I'm trying to build a perfect square trinomial, and I know that that magic amount that I need to add is b over 2 squared. So 4 divided by 2 is 2, and 2 squared is 4. 1, 2 squared. Okay. And so at the same time I'm adding 4 here, I'm going to subtract 4 here. There's no equal sign. If I had an equal sign and I were doing this, I would have moved the 5 over there, and I would be adding 4 to both sides. So this would be minus 5 plus 4, and that would work out just very well. But we don't have an equal sign. So as we simultaneously add 4, we need to subtract 4. So what are we going to be left with? Well, this factors as 1 over x plus 2 squared. And then, plus 1. And again, I say, hey, that's inverse tan again, right? 1 over thing squared plus 1. And if I do my u sub, it's going to turn out to be just tangent inverse of x plus 2. And am I evaluating this? No. Don't forget the plus c. X plus 2 plus c. That's choice A. A for number 4. Okay. 5. 5 gives us the integral of 6x squared minus 4x minus 25 over x minus 2 dx. Okay, so let's do some long division. I mean, I'm comfortable doing long division, but if you need to go through and try the other methods and say, Mr. Google, what about this one? Yeah, no. Sorry. 6x squared minus 4x minus 25. 6x. 6x squared minus 12x. And I subtract. Minus is plus. Minus 25. And so that's going to be plus 8. 8x minus 16. Subtract. And I get minus 9. So plus negative 9 over x minus 2. Great. So this thing that we couldn't integrate, and that was really, really scary, can actually be rewritten like that. Oh my goodness. So 3x squared plus 8x minus 9 ln x minus 2 plus c. I mean, really, that's so nice. Is that choice A again? Huh, I think they were kind of stuck for their choices. Okay, there's 5. How about number 6? 6, oh, another long division problem. Integral 12x squared 2x plus 1 dx. So, what if I said that this was a u sub? U equals 12x squared. So du would be 24x dx. And I would divide both sides by 4. And I don't have x dx on the same level. Yeah, not doing that. I only got one thing on the bottom, so it's not partial fraction decomposition. It certainly isn't completing the square, so let's just do the long division. 1 over x squared plus 0x plus 0. What do I multiply this by to turn it into this? 6x. And then I subtract. Minus 6x plus 0. So what do I multiply this by to make this? It's going to be negative 3. And it's negative 6x minus 3. And I subtract. And I end up with plus 3 over 2x plus 1. Okay, so this thing that I know what to do with except that it had a slant asymptote. This thing I can in fact break up into 3 other things. Okay, the antiderivative here is going to be 3x squared minus 3x plus. Now, I'm going to do that as a u sub because I don't trust myself to take this properly. So du over 2 is dx. So that is du over 2. That is our u. So I have 3 times 1 over u times du over 2. Okay? So I'm going to move this here. Okay, so that's going to be 3 halves. Whose derivative is that? Well, that's ln's derivative. So I have 3x squared minus 3x plus 3 halves ln of u. ln of 2x plus 1 plus c. So 3 halves ln 2x plus 1 plus c. That looks like choice C to me. C for number 6. Okay, 7. Ooh, completing the square. Completing the square. I've got 4 x squared plus 4x plus 8 dx. So I'm going to isolate the x stuff and have this plus 8. Okay, magic amount, b over 2. So 4 over 2 is 2. 2 squared is 4. But since I added 4 here, I have to subtract 4 here. So this is x plus 2 squared plus 4. So I'm going to replace all that stuff with this. Okay, so that's going to be the integral of 4 over x plus 2 squared plus 4 dx. All right, now this reminds me, oh, I'm going to take that 4 out. This reminds me of those problems we were doing in chapter 7, or was it 8? No, it was 7, where we said, oh, if only this were a 1, this could be inverse tangent. And so being Americans, we divided the bottom by 4, but we also know that we have to multiply by 4 as well. So I'm going to take this out here. It's going to give me 1/4 times the 4 that's already there. My integral 1 over of x plus 2 squared over 4 plus 1 dx. Okay, so what's my u? Well, my u is going to be the square root of this. So x plus 2 over 2 is my u. So, or u equals 1/2 x plus 1. Therefore, du equals 1/2 dx, or 2 du equals dx. So how can I rewrite this? Well, I'm going to have 1 u squared plus 1, but to get rid of this, we need 2 du, or 1 over u squared plus 1 du. Well, that's going to be 2 tangent inverse of u plus c. And our u value was this, 2 tangent inverse of x plus 2 over 2 plus c. That looks like choice D. Inverse 10, x plus 2 over 2, with 2 out in front. Nice. D. Okay. There's 7, 8. Ooh, long division. X plus 2 into 3x squared plus 2x plus 1. If I multiply this by to turn it into that, 3x. And subtract. If I multiply this by to turn it into that, is 4x minus 8, and subtract. That gives me 9 over x plus 2. So this thing that I was stuck trying to integrate, 3x squared plus 2x plus 1 over x plus 2 dx, could be rewritten as 3x minus 4 plus 9 over x plus 2 dx. And that should be pretty humane. Unless you've completely forgotten how to do all your derivatives and integrals because you haven't been working on that packet. And so, if you haven't been working on that packet, you should probably start doing 15 or 20 of those a day from now on. Because really, when we get back from spring break and we start that AP review, yeah, it's much more busy. It's much more work. The pace is much more relenting. And it is, in fact, the time not to fall behind. I have noticed people going into fourth quarter with a B, a nice solid grade, and then end up with a C overall and a 3 on the AP exam. Why? Because they didn't put in the time. No, really, they just didn't practice enough. They didn't remember their integrals, they didn't remember their derivatives, and things didn't go well. Just because we're done with new material doesn't mean we're done. So push hard, push hard. And then here, well, this is going to be ln of x plus 2. And if you're not sure about that being 9 times the ln of x plus 2, then by all means do a u substitution where your u is x plus 2. All right? This was an evaluate problem. We're evaluating from -1 to 1. So if I plug in a 1, I get 3 halves minus 4 plus 9 ln of 3 minus, I plug in a -1. 3 halves plus 4 ln of 1 is 0. So that's that. So 3 halves minus 3 halves minus 4 minus 4. It's going to be minus 8 and 9 ln of 3 minus 8. Okay, I think that's my answer. Minus 8, 9 ln of 3, that's choice C. I didn't even need to scroll down. Okay, that was problem 8. Let's take a look at problem 9. Is that it? Yeah. Problem 9. We have the integral 4x to the third to x plus 3. Now, that's a long division if ever I've seen one. 2x plus 3 into 4x to the third plus 0x squared plus 0x plus 0. What do I multiply this by to turn into that? Well, I need a 2x squared there. 4x to the third plus 6x squared and subtract. We get minus 6x squared. And what do I multiply this by to turn it into this? I've got a negative 3x. Minus 6x squared minus 9x and subtract. Minus a minus is plus 9x. But that's 9, and that's 2. That's icky, Mr. Kukla. Yeah, I'm going to have to multiply by 9 halves. So that's going to be 9 half. No, it's going to be 9x. Plus 27 over 2. And subtract. So minus 27 over 2 over 2x plus 3. All right, so this thing that I couldn't integrate is now going to turn into 2x squared minus 3x plus 9 halves minus 27 halves integral. Integral of 1 over 2x plus 3 dx. Okay. And so the reason I'm splitting this into two integrals is because I'm going to do a u sub here, and that'll tell me something about dx. And if I let that come over here to this dx, like if I apply this work to the rest of the problem, suddenly the rest of the problem is wrong. So, no. Okay, so here we've got 2x to the third over 3 minus 3x squared over 2 plus 9 halves x. And now, here, if u equals 2x plus 3, then du is 2 dx, or dx equals du over 2. Alright, so this is going to be 27 halves integral 1 over u du over 2. I'm going to pull that 2 out. So I'm going to have 27 fourths. And the integral of 1 over u is ln of u, so ln of 2x plus 3. And here we have our 2x to the third over 3 minus 3x squared over 2 plus 9 halves x minus 27 fourths ln of 2x plus 3. So what is that? That looks exactly like choice C. Choice C is my answer here, and that's the last one. Let Mr. Paz know if you need more practice, either with these long division ones or the completing the square ones. Really, what I'll say about doing the AP review is that if you stay current and don't fall behind, you're probably going to be getting a 5. No, really. If you do all the review packets, if you go over all those problems, if you stay current with each of them, even if you don't necessarily do really well in the first little AP quizzes, when you start doing the timed free response, I don't know, early April, mid-April, when you get into that period, that's when you should really start to feel a pattern, a rhythm. Oh, they're asking me this question again. That's when it would be good to do that, okay? But really, don't fall behind. After spring break, it's the time to push hard. No, really, it's college level class. It's college level grading. There's an expectation that you've owned all of this knowledge. So own the knowledge, okay? You can do this. I believe in you. I would have discouraged you from being in the class if I didn't think you had a chance of being successful with this. Okay. Well, have a wonderful day, everyone, and I'll see you in the next video.